Again, we welcome you all for the day 3 of this 6 days online Atal sponsored faculty development program on the topic IoT and cybersecurity in power systems, organized by the Department of Electrical and Electronics Engineering of our KLN College of Engineering. Welcome all the participants for this day 3, session 5. So this session is going to be handled by one of our renowned alumni of our EEE department, 2002 to 2006 batch. We are very proud to have you, sir, for this session. Engineer Palaniappan Sendil, sir. We welcome you, sir.
Thank you.
Yes. Before moving on to the session, let me have a short and a brief introduction about today's session speaker. So Engineer Palaniappan Sendil, sir, again, he's a renowned alumni of our EEE department from our own college. He's presently working as a project manager with PMP, Prince2, TOGAF, COBIT, and ITIL expert certified. He's presently working in a Cognite at Bangkok, Thailand. Currently working in the field of cyber and tactical intelligence for law enforcement agencies like Army, military, police, etc. in APAC region. 6+ years of experience in cloud migration, IT consultation, DC migration and consolidation, transition management, project program management, greenfield office setup, global network, service delivery in IT infrastructure, etc. His wings has been flight over many kinds of different sectors, and today he is going to deliver a lecture on the topic layers of Internet of Things. Sir, over to you, sir.
Thank you, Tangasad. Yeah. Okay. So, good evening to all of you here. Good evening, good afternoon. I'm really happy to share my knowledge on the layers of Internet of Things. So I'm sure like some of you know already some in-depth into IoT, but like we will now in this session go on a detailed level into the layers of IoT. So before I jump into the session, I would like to thank the KLN staffs and the Atal team for such a wonderful faculty development program, which is very important and motivating for many of you. So thanks again for the team. Today's agenda is, if you see, like in today's agenda, we will see about on a high level, what is IoT, why is IoT, so what is important about IoT, and then we will also see some interesting facts and case studies about IoT in other sectors. So once we complete this areas, we will jump into the layers of IoT. We will go into each of the 7 layers, and we will also see IoT protocols. And to close the session, we will have some interesting facts about IoT. So the key intention of this session is not just to share the technical knowledge, but it is also to bring more eagerness and importance of IoT to all of us. So this way, once we have more eagerness and once we know the importance of IoT, we will start digging deep into it. So that is the reason, and maybe many of you here in this session would develop your students coming into the IoT field as an entrepreneur, or you yourself can invent something in the field of IoT, or you yourself can become an entrepreneur in IoT. So this is why we are going into this session. So I know most of the training sessions, I don't want it to be a one-to-one session. So I want it to be an interactive session. So here let's do a small ice-breaking game or a time exclusively for a game, so that I want it to be a both-way communication. So if all of you can take your phone and scan this QR code, we will have a small game. Or if you don't have a phone to scan, you can go to menti.com in Google and then type this code 8661 8011. Kindly let me know when some of you have already done it, so that I can I can jump to the game. If you've connected to the menti.com, just raise your hands. Okay, I see one raised hand. If some of you can just raise your hands. Okay, I could see two. Okay, a few others fine. Then okay, three. Good. Okay. Because we want the session not just one way where I keep going on to the slides, I keep next, and I share the slides. Rather, I want it to be a more interactive session where I also want to know from you. So this is why we are doing this small game. It's more of an ice breaking, like not the trend. We don't want it to be a boring one session. So okay, I could see 5. Okay, there are 68, 69 participants. If we can have at least 10, we can start the game. If you don't have a phone to scan the QR code, you can go to Google, type menti.com, and then type this code. It will take you to this page for the game. Okay, I guess we have enough. So let's go to the game. So I would like to hear from you. What is your understanding of IoT? See, like we all have our own understanding of things, right? So I would like to hear from you. What is your understanding of IoT? You can give with not more than 3 words, whatever you feel. What when I say the word IoT, what comes into your mind?
Mission to mission communication, sir.
Uh, Thank you, ma'am. Do you mind typing it in the game? So, okay, so someone thinks it's a network of stuffs. Someone thinks it's a sensor-based data transmission. Very good. Okay, someone thinks it's an automation. Good. Okay, it's a world of sensors. Okay, good. Things connecting to internet. Very good. We got 5 people to answer. It's an ocean of knowledge. Yeah, excellent. Yes, true. It is. IoT is a never-ending field, and every day IoT is being innovated. True, very true. It is an ocean of knowledge. True. Can we have more people to join? Okay, internet connecting to the world. True, very true. Connection of devices. Nice. What else comes to your mind when you think of IoT? Smartness. Okay. Perfect. Okay. Thank you. So at least I got some 11 to 12 people. Thank you. Sorry, ma'am? Nice. Interface with devices. True. Thank you. So all of your thoughts about IoT is all right. Yes, it is. It's all very appropriate, and it's right. Let me know if you're now seeing the screen, the blue screen. Okay, so I guess yes. So So what is IoT? What is the official definition of IoT? So we need to see the evolution of IoT, right? So if you see humans before were talking to each other, but then today we use telecommunication field or mobile technology to do the same job, right? Our communication, which was nearby and person to person, changed now to the telecommunication field. Similarly, the world of computers were connected via cabling infrastructures and LAN infrastructures. But today, it has gone beyond. Now the cables are being run through oceans, now via satellite. So now it is through internet. Similarly, for the IoT, IoT is nothing but the devices of sensors and machines, right? So obviously these things, the sensors, machines wanted some way of communication. Initially, it was through physical cabling. So a sensor was connecting to a control panel through a physical copper cable. But now, again, these things wanted a world to connect, and that's where the evolution of Internet of Things came. Here, one interesting news about the word Internet of Things is that in 1999, a person called Kevin Ashton was the first person to come up with this word Internet of Things. So he came up with this word during a discussion, and that became the name. So official definition in Google that you would see is IoT is the network of devices that are connected and can exchange data with each other and other systems. So this is basically the definition that you see. And let's jump into why is IoT important. There was a survey in the year 2023 or 24, which was done with the major industries, where the industries were asked what is their expectation of most profound technology that is impacting their organization. And on the left, you see the survey results. The top 4 technology: big data analytics, cloud infrastructure, artificial intelligence, and IoT. Among all of these technologies, IoT ranked the top. So which means that the top trending industries have recognized or have already analyzed and confirmed that IoT is the future, and it is the most important. So this is the first reason why IoT is important. If I need to add more reasons on why IoT is important, second reason you can say is the cost benefits and the cost reductions that IoT devices can bring. So in the upcoming slides, we will see few case studies and examples where really many large companies and giants have done a huge cost reductions with the IoT technology. Next, it also helps in accuracy, bringing in efficiency into the system, be it whatever field, production, manufacturing, homes, bringing efficiency. Then it also helps in mobility. So without IoT, there are certain areas where we cannot even think of mobility. So only because of IoT, we were able to get mobility in certain technologies and certain fields. Yes, as someone rightly said, it gives the capability of automating. Next, why is IoT important? It brings a lot of productivity. And this, again, we will see many case examples and case studies where many companies have reaped productivity because of IoT. Next, why IoT is important is to gain faster communication and also to build the best customer experience. So if you still ask me why is IoT, there are many other fields. The market of IoT in 2019 was 726 billion market, and in the year 2023 it became a 1.1 trillion market. And Currently, India alone is spending $20.6 billion in this market, and it's still growing. So this is the data from 2023. So which is again a key reason why we all need to understand that IoT is an important field that we are entering into. And if you still ask why IoT, it's because everywhere I'm pretty sure you turn to your left, right, your front, you walk out of your home, you walk out of your college, everywhere you see is IoT. So this is the other reason why IoT is needed, or IoT is important. So let's quickly see a few other IoT in other sectors. So if you take consumer electronics, there are like whatever the phones that we're holding, the smartwatch that we're having. So basically any device you take and you add an IoT capability into that device, it becomes a smart device. So you take a bulb, you add an IoT device or IoT sensor into it, it becomes a smart bulb. Similarly, a vacuum cleaner, you add the smart IoT capability into it, it becomes a smart vacuum cleaner. So I will give you an example. So this is the case example, where there is a building in Amsterdam. The building is called Edge Building. In this building, there are 28,000 sensors that are continuously measuring the building occupancy and movement of employees and people around. And these sensors will help to optimize the lighting levels, humidity, and temperature. So like with this technology, they can control the climate settings, and it can even guide the workers to find the free parking spaces. Imagine we going to a mall and then running around, looking around for parking spaces. Such kind of sensors and IoTs can help you find where exactly the free parking spaces. And like in this building, they were even able to do an occupancy scheduling or booking. So this way, if you want a meeting room or a work area to be booked, you can do this. And it can also help you locate colleagues within the same building, even order dinner via the app. Another interesting fact in this Edge Building that they have done is based on the sensor data. So it's not just alone the real time, it is also about the data generated. And with the data generated, they were able to analyze that there were certain areas that was not used. So the cleaning of that certain areas was delayed or not done. So let's say, for example, there are 10 floors and only floor 1 and 2 were highly utilized. So only those floors were informed to the cleaning staff for cleaning. And it was also helping the workers to refill coffee machines. And in this building, they also had a security robo, which patrols the office normally. And the interesting part about this security robo is it takes a snap of the entire office every day or every minute. And if it sees something missing, let's say, for example, there is a chair which was taken on day 1 picture, but the day 2, there was no chair at that location. Then it will send an alert to the facility team, and they will start looking for the missing item. So this is a case study where in this building in Amsterdam, IoT was utilized and the maximum benefit was taken. Here, as I said before, you could have seen there is efficiency, there is cost reduction, safety, all benefits are being reaped out. Let's go to the next sector where IoT is used. I'm sure many of you would have seen or already using it, that this is the IoT sector in health, where most of us are wearing the watch, the smartwatch, which is a classic example for an IoT device. All of us are having it in our own body. The advancements of IoT in health sectors are, another example is the Holter device that continuously monitors your heart readings for, let's say, 3 days, 7 days, or even a month. There are enamel sensors that are placed on the teeth There are the ECG sensors that you use. That's also an IoT device. There are ring biosensors, which keeps monitoring the HR, the heart rate and BP and temperature. There are smart pulse oximeters, armbands, temporary tattoos, neurostimulators. These are all some of the examples of IoTs in health sector. I'll give you another example of how IoT in health sector is benefiting. There is a San Francisco-based company called Livongo. So they specialize their products for diabetes, and they have additional products that address hypertension, weight management, and behavioral health. So how they do it is their device, their smart device, which is a blood glucose monitor that keeps transmitting data in a real time. And based on the data that the company receives, they provide a personalized information in a form of email, phones, and they also provide free online coaching to improve their health. So how smart this device is that for within 90 seconds of seeing a troubling blood sugar, the person will get a call asking if he's okay because his reading is going abnormal. So and to go one level beyond, this Livongo is tying up with Amazon Alexa. So every time you want to know your blood glucose reading, you don't have to open your phone and ask. You can just ask Alexa, what is my blood glucose level now? And then it will tell you the reading. So this is how smart, and this is all being done because of IoT. It is possible because of IoT. The next sector is automotive sector. Like, why we are talking about different sectors, you might ask a question. I'm into electrical electronics field, or I'm in an electrical department, but why am I saying into other fields? This is because when we start looking into other areas, we will get more ideas. So from a health area, we might find something that we could use in our own area. Similarly, like if you start looking into every areas, we will get more ideas to implement. That's why. So in an automotive, a classic example of automotive is the Tesla car, which, as most of you know, is like the heights of IoT device. So it has 8 surrounding cameras, and then it has a specific forward-facing sensor. The sensor is so powerful that it can penetrate through heavy rains, fogs, dust, and not even that. It can penetrate through the vehicle that is in front of you. It can go beyond. If you would have seen the Tesla videos, it will show you even 2 levels beyond what cars or people are going. So that's the level of the sensors that's used in the car. Similarly, another example of automotive field is there's a company called Metromile, who is a insurance-based company. Basically, they specialize in car insurances, and how they have done or how they have implemented IoT and benefited is they have installed telematics devices on the customer's car. And what these sorry, 1 minute. Yeah, sorry. So what these cars with these telematics device do is that they send real-time data to the insurance company. So let's say, for example, if there is a driver who's driving very smoothly without any rash driving, then this customer will get a reduction in their premium. But let's say in another example, if the driver is a very rash driver and he's doing reckless driving, in this case he will get a more higher premium because there are higher chances of accidents in this car. So this is one example how they have used IoT for the benefit of insurance industry in automotive. And the other interesting fact is that they were able to find 92% of the stolen cars that were reported. This was because there were devices implanted, and with GPS tracking, they were able to find. So this is another case study of how IoT is benefiting in automotive industry. Next sector that we could see is the agricultural environment. Like here, I will again go with an example. See, today the global population is growing day by day, and we are expected to reach around 9.7 to 10 billion by 2050. So imagine how would a farmer or the agriculture world cater to the food needs of this crowd, right? So companies like Microsoft already started thinking about it, and Microsoft's company, which is called as FarmBeats, have invested a huge money into IoT field, where they are collecting data from sensors, drones, satellites, and tractors, and they feed these data into artificial intelligence interpreters. And how they are collecting these data is a very interesting way, because it has to be collected from all over the world. They use the TV white spaces, which is an unused broadcasting frequency as of today. They're using this frequency, and they are transmitting these data, and they are processing this data. So they're using Microsoft Azure to process the data. There are close to 200 farms in United States which are currently working on this model. They monitor the soil temperature, humidity, acidity, wind speed. They can even predict the water budget. So let's say there's going to be a drought in the next 3 months. They can predict that, okay, there's going to be an X amount of money that will be needed to water the fields. So this is how the data is used both in real time and also post real time. The data is used to analyze and predict the future. One more interesting industry where IoT is heavily used is the manufacturing industry. So there are very different types of sensors that are used here, like gas and flow sensors, for load sensors, motion sensors, temperature sensors. So let's see another example how this is another example where the famous BMW company, the German company, has implemented IoT. So out of their 7 manufacturing units, they have incorporated 3,000 machines and robots and autonomous transport systems into their IoT system via the Azure cloud. And how they benefit is, let's say, for example, there is a unusual noise detected in the drivetrain or the assembly unit. Then it will be informed to the mechanics, and the mechanics will be dispatched to this area, and then they'll start inspecting where the unusual noise is coming before anything serious happens. So this is how it is benefiting. But here, if you see, this is a real-time data. But then with this data that is received, they do process the data, and they do a predictive maintenance. This way, they're able to reduce unplanned downtime for the shops by 25%. So here we might think, okay, how does it benefit? 25% of downtime in a manufacturing industry means big money, very big money, because for one car to come out of a manufacturing plant, let's say it takes 1 month, this 25% is a very, very significant amount that can help in their production capability. So every minute, every hour in a production plant is important, and such kind of 25% downtime reduction is going to help them in a large scale. One more example for a manufacturing industry is the famous L&T groups, where they have implemented the IoT technology in more than 10,000 machines across 450 work sites. They have RFID tags placed on the materials and the worker's helmet and the equipments. So how they benefit is they can track the employees, where they are moving around, how safe are they. Let's say, for example, there is one area, how crowded it is with the workers, where are the materials moving. Uh, so all these kind of tracking uh, will help in productivity, and it has resulted in 25% increase in the fuel efficiency, and also an increase in workers' productivity. So here, what we saw here is all like productivity and like cost efficiency and all this. But in addition, it also brought a lot of cultural changes in people. So there's a lot of significant cultural changes when there is monitoring and things. It is safe. It brings a safe belonging to the employees, and these are that's an example of how L&T did it. Another sector is the shopping sector. This is another case example where Amazon in 2018 started a store called Amazon Just Walkout. So this concept, if you see, is a no cashier and no register concept, where they use like computer vision technology, sensor technologies, and then deep learning technologies, where a shop will immediately predict a customer entering the shop with a credit card, and then he takes a product out of the shelf. It will add the product to its virtual cart. So this is how advanced it is. You don't have to take the product, go to the counter. The minute you take the product from the shelf and put it into your basket, it adds to your virtual cart. And similarly, if you take back and put it back to the shelf, it will remove the item. And you just have to walk out. So no billing, nothing needed. And once you walk out of the store, you will get an SMS, you will get an email with receipt, and the money will be debited. This is how IoT is used. And Amazon is implementing this all over the world. Okay, another quick game time. Now that we have seen many examples of how IoT is being used, I would like to quickly jump to another game. If all of you can take your phones, scan the QR code, or go to menti.com and type the code. Please give me a thumbs up once you're logged in. So you have to take your phone, just point your camera, open your camera and point your camera at this QR code and click on the link. It will take you to the menti.com, or you can open the browser, go to menti.com, and then type the code. Good. I could see 10, 11 people joined. Okay. The intention of doing this is, we don't want the training to be, one-way session where I talk for the whole 1.5 hours and then I say thank you and bye. I want it to be a two-way session. So I kindly request everyone to just join this menti.com or just scan the QR code. And it's a small game, just for a few minutes, and then we can. Okay. Okay. I guess we have 16 people. So let's jump. Okay. So now that you've understood how IoT is being used in different fields, I would like to hear from you, which are the interesting IoT devices that you have seen or used? I repeat, which are the interesting IoT devices that you have seen or used? You can give 3 options. Okay, AC control, very good. Yes, we have home AC controls which can be controlled via smartphone even when you're 1,000 kilometers away. Home automation, fan controls, perfect. Yes. Smart TV, smart watch, refrigerator, true. Okay, okay. ESP32 Wi-Fi model, smart refrigerators, Holter. Oh, true. Yes, Holter is a heart monitor system. True. Smart city, smart meters, automobiles, smart relays, face scanners. True. Automatic door locking. Nice. 32 responses. Very good. Thank you. Okay. Thank you. Thank you. Step counting. True. Yeah, these are all, yeah, yeah, right. These are all some of the interesting ones that we are using in our daily life. True. Smart light. I still remember when during my school days, I'm sure many of you will have also seen it. We used to be amazed by the clap switch. So when we clap, the light will turn on, and when we clap, the light will go off. That was an amusement in those days, but today we can control from wherever we are. Smart fans, Tesla, yes, true. Vacuum cleaners. Thank you, thank you, thank you all. Okay, let's quickly jump to the session again. Okay, so now we are jumping into layers of IoT. When you see this diagram, like there is 7 layers, right? Like you could see these are the layers of IoT. When you see this diagram, I'm sure you can relate the 7 layers to something. Like our 7 chakras. So how we reach to the cosmic world. Similarly, the IoT also has 7 layers through which it comes to the productivity. So we will jump into each of these layers in detail, and this is where we're going into the complete technical part of it. So first and foremost is the physical device or the control layer. If you see, this layer is the most important one, where it incorporates with tons of IoT devices and IoT sensors. So when I say tons, it is the meaning itself matters. There's not just one sensor. We saw an example where in a building there was 28,000 sensors, right? Imagine in a manufacturing unit, there could be millions of sensors in just one factory. So this is the first layer where it has to incorporate all the sensors, wide range of sensors. So it's not just one type of sensor. It could not be just temperature monitoring sensors. It could be different types of sensors that is incorporated in this level, which is the first layer. And if you see sensors, some of the sensors, there's no rules about size, location, form factors, and origin. Some of the devices can be size of a small silicon chip. Like we saw an example where in a health sector, there was a small chip that was implanted on a teeth. That's like the smallest size of a device, and even the largest, it can go up till the largest one to a size of vehicle. So the first level is the physical layer of IoT, where the sensors are incorporated. So here the analog to digital conversion happens in this layer when it's required, and the first interaction or the first generation of data is happening here. Second layer is the connectivity layer. So here, the most important function of the level 2 is generating a reliable and timely information. See, imagine in the level 1, the sensor is generating a data that there is a temperature going above a set limit. But if the layer 2 is not working properly and it's not giving the communication on time, let's say it is giving after 1 hour, the accident would have already happened. So the level 2 is a very critical layer where it is important for the most reliable data and the timely data. So level 2 is actually, this includes transmission between devices that are in level 1 and also across the network. So if you see east to west, it has to communicate, and also to the next level, it has to communicate to the network layer. So this is where the devices like gateways, I'm sure you would have heard about, for the smart homes, for all the door sensors and all those, you will see a small modem-like device. So let's say there's a door sensor, there's a temperature sensor, gas leak sensor. All these sensors will connect to a small box, which is like a gateway. So gateway is a classic example for a connectivity. And what the layer 2 gives the data to the layer 3, which is the edge computing layer. So many of you would be wondering what is edge computing. Edge computing, I can give you a very interesting example. Edge computing is like, I buy, let's say I buy tomatoes from a retail shop or a supermarket. This is normal computing. So because from a farm, the tomato comes to a distributor, and then the distributor takes it to a supermarket, and then I go to the supermarket and buy it. So this is like normal computing. Rather, if I, instead of going to all these supermarkets, I directly go to the farmer where it is produced, the source of production, that is called as edge computing. So edge computing is nothing but the computing which is done at the data generation level. So there is no loss of data because it is done right at the level where the data is generated. So that is edge computing. So here in this layer is needed to convert the network data flows into information that is suitable for storage and higher level of processing. So for example, okay, level 1 has sensors. Let's say there is a temperature sensor. That sensor will work every second, 24 hours per day, 365 days a year. So it will, the first level sensor keeps on sending data, and that is why this layer gets fogged with the data. And that's why we use the terminology fog computing, because this level 3 gets tons of data and it's fogged with many data. That's why we use the term fog computing. So here, the level 3, the processing is done on a packet by packet basis, and then it is sent to the next level, which is level 4. So in this level 4 layer, the data accumulation happens, or the storage happens. Here, if you see, as I said, there is tons of data coming. So the data is all very volatile and very moving. So the data is in a high motion, and the data has to be put in a rest. So this key action of putting the data into rest happens in this layer, where all the accumulated data is put into rest and can be used for the next level. So here, if you see, the event-based data which is generated from the sensor. So a sensor event-based data is converted into a query-based data in this level. So the data will stop until this level, and only when we run a query or when we ask the system to fetch automatically or by automation, that's when the data is fetched from this. So that's why this layer converts the event-based data into a query-based data. So from level 4, the next level is the data abstraction level. Where, as I said, there are data coming, right? So in the level 4, there were tons of data. So now we need to, all these tons of data need to be packed into queues or packed into schemas. So that happens in this layer where the data is kind of segregated and kept it into schemas. See, schemas is nothing but, let's say, in our schools, we would have seen, right? Let's say there is 300 students in a school, and we make the students stand section wise. So from LKG until 12th standard, we make the students stand. Similarly, that's a classic example of what happens in the level 5 here. So the datas are kept into schemas. Schemas is nothing but the database schemas where the datas are segregated and kept for simpler fetching. So here the rendering of data happens, and the storage, this layer stores in a way that enables a simpler and a performance enhanced application fetching. So this happens in this layer. So we saw about 5 layers. Next is the application layer. So till now it is all in a form of data. We might not even see it in our eyes. So for a human to interpret, we need to convert that data into some form, and we need a platform to convert, right? So this is where the level 6 comes in, where this is the application layer, where the reporting, analytics, and control happens in this layer. Basically, the interpretation. So with the data, if example, I'm given 1 million data records of a temperature sensor, I can't go into 1 million data records and then find what is a problem. So this is where such kind of applications which focuses on monitoring, and some applications even focuses on controlling devices, and some applications focus on both controlling and monitoring. This does the work. So it collects the 1 million records, and then it gives back in a usable form to us, or a GUI interface to us. So this layer is where the key interpretation of data occurs in the layer 6. Okay, the layer 7, or the final layer. Okay, so let's say, for example, okay, here in the application is showing that, okay, there's an alarm or a sensor which is showing a limit breach. So what do we do with that? If there is no action done with the data, it's useless, right? So the IoT has done its job, and it has given the interpreted data to us. But if you don't take an action, it's useless. That is where the level 7, where the collaboration and process layer comes into place, where the data is given to a people or into a monitor or via call form. So an alert call or an alert SMS or an email. So it prompts to the people or to the process to take action. So the information it creates is of like very little value if there's no action taken, right? So this is why we need people and processes to come and take actions accordingly. And in some cases, it is not just people alone. It is the automated process that uses and takes the expected outcome out of IoT. Okay. Next, by the way, before I jump in, any questions so far in the level 1 to 7? So we saw about physical layer, connectivity layer, edge computing or the fog computing layer, data accumulation, where the storage happens, and the data abstraction layer, application layer, and the process and collaboration. Any questions so far?
So connectivity layer, any specific operation?
Sorry, connectivity layer?
You have to need any low power applications, sir? Because IoT devices is operate the very less power. How high speed data it will be managed then, sir?
Exactly. Yeah. Thanks for, first of all, thanks for asking this question. Yes, you're right. So see, not like all the IoT devices are sending a very low power, rightly pointed out, like Bluetooth signal or a small Wi-Fi activate signal or an NFC signal, which is very minimal. So this is where the connectivity layer comes into place, where, as I said, there are devices called as gateways. If you Google smart home gateways, it's more like a square box. So the main work of gateway here is to connect these low power sensors and then gather the data and then send it to the next level. So this is where the connectivity layer comes into place, where devices like switches. Another example of connectivity devices is switches. So gateways, switches are all classic examples of connectivity layer devices, where it acts as the these are like not high power devices. Normally it might operate in a normal voltage, like for example in smart home it's a 12 volt. In a car, again, it's a 12 volt. These devices will pick signals from these. Let's say in a car, a gateway is like the heart of the system, where it picks from a tire pressure and outside sensors. It picks the signal and takes it to the next level. So gateways acts as the connectivity layer devices. Gateways, switches, network switches, panels.
Thank you, sir.
Does that answer your question?
Hello, sir.
Thank you. Yeah.
So these layers are application specific or it is mandatory for all IoT applications, sir?
Sorry, it was broke. Sorry, like these applications are, sorry?
So these layers are application specific or it is mandatory for all IoT applications?
Okay, very good question. Okay, for this, allow me to go back to the first slide. Okay, so your question is that, do we need all layers for all IoT? No, the answer is no, because there are very simple IoT devices where you don't need all these layers. You can even do a small, if you have small devices, you can do your own home automation, a small IoT system in your home with just 3 or 4 layers. But the most important layer, you will always need layer 1. Without this, you can't do anything, because layer 1 is the sensors and devices, right? So mandatory is layer 1. Second layer is also mandatory, because without the second layer, you can't connect the devices. But again, the third layer, fourth layer might not be needed. You can directly go into the 7th layer. So if you want a very minimal one, 1, 2, and 7, you can do a small automation. So with a sensor checking, and then the sensor converting the data, and then let's say it's showing in a light form. Okay, so it is 1, 2, and 7. If you want in an application, if you want to capture the data, and then if you want to manipulate the data, then you will need again level 4, 5, and 3. So for example, in your home, you want to do a small automation. Okay, so you want to check a gas leaking. You buy a gas leaking sensor. This is level 1. Okay, level 2, you use a small microprocessor or a board. That's the connectivity layer. And layer 7, you can use a simple LED. Like if there is a gas detected, there is a light which glows. Here, if you see, it is a real time. Okay, let's say you're not at home. The sensor activated. The bulb got glown because it detected a gas smell. Okay, but you were not there at home. But when you come back home, you see the light is not on. Does it mean that there was no gas leak? This is where, if you have a layer 4, 5, and 6, what happens is, even when you're, let's say you do the same automation at home, but with 1, 2, 4, 5, and 7, okay, you come back home, it will show that at when you were outside the home, there was an incident where there was a gas leak. This is where the data accumulation and data abstraction comes into place. If you want even to further automate, that's where layer 6 will come. Let's say, for example, you want to see in past 1 year how many times the thing happened and what is causing the thing. Okay, so let's say if you add the layer 6 of application, you will see that only during the summers there was a gas leak, but during winters and autumn there was no gas leak, which means you can analyze, and the artificial intelligence also will help you, saying that during summers there was a gas leak at your home, but during winters there was no gas leak. So this is why, if you want a full-fledged IoT, you need all 7 layers. But if you want a very minimal IoT, you can still do it at layer 1, 2, and 7. So I hope that answers your question.
Yes, sir. Thank you.
Any further questions before I jump to the next slides? Thank you. But by the way, like, these questions are making the session more interactive. Thank you. Okay, let me go to the other slides. Let me check the chat if there's any. Also, whoever is the moderator, if there's any questions in the chat, feel free to let me know. Okay, so someone is texting me. Okay, someone I know has messaged me saying I look very young in the picture. If you want to know the secret for my youngness in the picture, is because for the past 20 years I didn't change my profile picture. So that is why. Thank you. If you have any questions, feel free to ask me in the chat. Thank you. Okay, I'll go to the next slides. And the person who asked this question is like known to me, so thank you. Okay. See, like for every technology communication to happen, there's always protocols, right? So protocol is basically like let's say I'm human to human talking. I'm using words, so words is a protocol, right? So similarly, I'm far away from a person and I'm sending him a letter or an SMS. So it is a letter protocol or a SMS protocol. So the medium that I'm using to communicate, so that's the protocol, right? So here we have segregated the communication protocols into each layers. So there is a link layer, there is a network layer, and there is a transportation layer, and there is an application layer. Okay, so initially we saw 7 layers of IoT, but these are the 4 layers of communication protocols. So I'm sure some of you would be very much well versed with these things. So if we see the link layer, the first and foremost is the 802 Ethernet layer, which is nothing but the wired Ethernet standards, right? It's a wired layer. So .3 is a coaxial cable layer. .3.I is a copper layer. .3.J is a fiber optic layer. So whichever layer, okay, it could be any of the Ethernet layers. Similarly, like the 802.11 Wi-Fi layer, like Wi-Fi 5G band, 2G band, 2.4G band. And WiMAX is the wide band for wireless broadband standards. Yeah, broadband standard. Yeah, it provides a range of WiMAX signals, and the data rates are somewhere 1.5 to 1 GB per second. So it's like this is also one layer that we could use. Or the LRWPAN, which is the low rate wireless personal area network. So this is highly beneficial for for devices like Zigbee and all those. They use this channel. And obviously the cellular channel. So 3G, 4G, 5G, definitely not 2G. So yeah. And next, if we go to the network layer, the most famous is the first two, which is the IP version 4 and IP version 6, which is very widely used. IP version 4, you know, is like a total of 2 into 32 addresses. But because we were running out of IP version 4, so obviously someone has to invent IP version 6, which is 2 into 128 addresses, which is like a wide range of. Maybe after another 50 years, we will have IP version 8, maybe, when we are running out of IPs. So just some interesting history behind IPv4 and v6 is that same like our landline and mobile technology. Initially, I remember when I was a kid, I used to have a 5-digit or a 6-digit home landline number, which was just 4 or 5-digit number. But then later, when we started having mobiles and more devices were coming, obviously 4 or 5-digit was not suffice. So we went to like 10-digit numbers. Similarly, in the world of IP internet protocols, we used to have IP version 4 before. And then when we were running out, people invented IP version 6. 6LoWPAN is nothing but the IP version 6, but over a low power wireless personal area network. This was also invented, but not widely used in the IoT area, but still used in automobiles and other sectors of IoT. And next, if you see the transport layers, there is two predominant ones, the TCP and the UDP one, which is the transmission control protocol and the user datagram protocol. So finally, the application layer, which is our layer 6, where the data interpretation happens, right? So this layer uses technologies like communication technologies like HTTP, which is the common wide one, CoAP, which is the constrained application protocol for machine-to-machine language, WebSockets, MQTT, XMP, which is the extensible message and presence protocol, DDS, which is the data distribution services, and AMQP. So these are all other communication protocol technologies where the application layer of IoT uses these technologies. So just a short recap. So there are 7 layers of IoT. So the first layer is the physical devices layer, second layer is the connectivity layer, third layer is the edge and fog computing, and the fourth and fifth layer is the data accumulation and abstraction layer. Sixth is the application, and seventh is the collaboration or process layer where people are involved. So now you can relate these 7 layers into the protocols, and you can see where these will be used. Okay, if no further questions, I will move to the next slide. Any questions from anyone?
Sir, could you
Okay.
please explain edge computing?
Edge computing, sure. Yeah, thank you. Thanks for asking. I gave a very interesting example. Allow me to repeat the same example. Edge computing, I was giving an example of tomato, right? So I want to buy tomatoes for my home. So I go to a supermarket, I buy tomatoes. Okay. Where those tomatoes come from? From a farm. The farmer reaps the tomato, he sends it to a distributor, and the distributor gives it to a supermarket. So basically, what I'm doing is the computing, not edge computing. But if instead of me going to the supermarket and to the distributor, I directly go to the farmer or even to the field and I pluck my own tomatoes, That is edge computing. So which means a computing which is done in the layer where the data is generated, that's called as edge computing. So any layer, immediately when the data is generated, you go there and do the computing. That's called as edge computing. Does that
Yes,
does
sir.
that answer?
Thank you, sir.
Yes,
Thank you.
sir.
Thank you,
So
sir.
then, sir, this is different from cloud computing.
Yes, yes. Cloud computing is different. Edge computing is different. So edge compute. So for example, like I was giving an example of your gas leak monitor, right? So you have a sensor at your home which is monitoring the gas leaking smell and the smoke detecting sensor. Okay, you connect your laptop directly to that sensor. That is edge computing. So the computing which is done immediately at the data layer, that is called as edge computing.
Then, sir, how do we select which computing technique will be suited for my application, whether it is edge computing or cloud computing kind of thing?
Okay, so here, okay, good question. So here, okay, allow me to go back to this slide. Here for this data accumulation, which is level 4 and level 5, people can use cloud computing because when you generate tons of information, okay, so here you will be generating tons of information every day, every minute, yearly, 365 years per day. And if you don't have such a computer infrastructure to store those data, you can go for cloud computing. Okay, but this is I'm saying only if in a case of a manufacturing plant there are millions of sensors, millions of data generated every minute, every second. In those cases, people have to look into cloud computing or even physical computing. See, wherever you want to reside the data, if you have money and if you have space to have let's say 1,000 servers and I can run my own data farm, you can go with physical servers. But for cost reasons and for easy reasons, people opt cloud computing, and that is where level 4 and level 5 data goes into the cloud computing. So edge computing, there is no substitute. So to answer your question, do I have to choose edge computing or cloud computing? These both are completely different. Edge computing is different, cloud computing is different. Edge computing is nothing but gathering the data right from the source of data sensors. That is edge computing. See, imagine if you have a sensor at your home, but you run a cable all the way somewhere else, and then you're processing it after later, you will have data loss, right? So to avoid the data loss and to get the accurate, reliable data, edge computing is used. Edge computing is nothing but doing the computing. There's no hardware for this. It's basically the terminology which explains that you do the computing right at the level of gateways and sensors. That is what is edge computing. Okay. Does that answer your question?
Yes, sir.
Okay, thank you. I have 10 more minutes, so I will try to finish the slides. Okay, so to finish my session with an interesting fact, I know, like, I don't want it to be I've tried my level best to not make this into a boring session. Rather, I want it to be a more interactive and a meaningful session. Because, see, today all of us, I could see there are more than 98 people in this group. All of us can study about IoT with just a computer and Google and things. But what I'm trying to do here is to deeply embed the importance of IoT into all of you, because let's say 30 years before, if someone would have come to us and said, you know, everyone will be having a mobile in hand, we would have said, no, sorry, mobiles are very cheap and mobiles are like a rare piece. We will not be having it. Similarly, IoT is the future, and you will see it's already a future, by the way. sorry, we are already in the world of IoT, but you're going to see drastic improvements in the field of IoT. So my key intention of this presentation is to give all of you the importance of IoT and seed IoT into all of you so that you can dig deep into it. So to conclude my presentation with more interesting facts, I've just gathered something just to end with the interesting facts and not with the boring one. So as I stated before, in 1999, a person called Kevin Ashton, he used the word Internet of Things first time. So he's not an inventor, but then like he was the first person to use the word because he was working in the field of network RFIDs. The next interesting fact is that as of 2023, there are 16.6 billion IoT devices, which is twice the world's population. So you can imagine that everyone in the world in the year 2023 would have had 2 IoT devices per person. Imagine now we are in 2025, we would have been going very rapidly growing, right? The next interesting thing is that the first IoT device was used in a Coca-Cola vending machine at Carnegie Mellon University in 1980s. So the machine was using sensors and it was vending the Coca-Cola, and when coins were put, and then it was dispersing the Coca-Cola cans. So next interesting fact, sorry. Yeah, the next interesting fact is that the global smart home market is expected to be worth of 537 billion in the year of 2030. So that's like a huge volume. That's way beyond some countries' GDP and all this. And IoT industry is projected to reach 1.5 trillion in 2030. So these are some of the reasons to prove again that IoT is already growing and it's going to be the future. Another interesting fact is that farmers use IoT ear tags and sensors on the cow, so to track their movement, to improve their health, cow's health, and to improve the milk production. So this is in Switzerland that was done. And another interesting fact is that in Barcelona, they saved $37 million annually just by using smart street lights. And this is the reason, if you see, most of the countries today are jumping into smart cities, smart city programs. And smart city programs is nothing but converting your cities into IoT capable cities. And one more interesting fact is that the Mars rovers that is used by NASA, that is using IoT, and it is transmitting millions of data through millions of kilometers away. So this is again, these are all some of the interesting facts to prove that IoT is the future. And with that, I guess I have 7 more minutes. If you have any questions, I'm happy to answer. If not, I would like to conclude the session if there's no further questions. Any questions from anyone? And to end the session, and I'm proud to say that I'm a student of Mr. Kannan, Mr. Lobandurai, Mrs. Nanambal, Mr. Marimuthu, Mr. Pushpavanam. Maybe I'm missing. I'm trying to see the people who are in the session. Maybe I'm missing. I'm happy to say that I'm a student of all of them, and thanks for giving me this opportunity.
Sir, thank you so much, sir. It's really a very good insight, sir. Actually, the examples of tomato for teaching layer 3, we haven't seen it anywhere else, sir. See, we people who are teaching IoT as an young professional, it's really a useful thing though, so that we can take this kind of examples to the next generation who are going to really experience the IoT things, sir. Thank you so much for a very fruitful session to you, sir.
Thank you. Thank you all.
Palniappan, very good, Palniappan. Your presentation was very nice.
Thank you, sir.
Very good.
Thank you.
Palaniappan, thank you so much for your wonderful presentation.
Thank you, ma'am. Happy to hear all of your voices after many years.
Thank you. Thank you for sharing your technical knowledge with all the participants. Thank you. Thank you so much.
Yeah. And I must admit the fact that I'm not into teaching profession, so I'm into a different profession. So for me to prepare these slides, I was imagining what noble job you all are doing, that every day you're preparing for your classes. For me to prepare this session, it was very difficult, but then like I could imagine that you're doing it on your daily jobs. Very hats off to all of you. You're all
Which
doing.
is very interactive. Participants also are highly interactive. So very useful to all the participants. I think so. Thank you.
Thank you, ma'am. Thank you.
Thank you, Palaniappan. This is Pushpanam.
Thank you, sir. How are you, sir?
Fine. Yeah, nice presentation.
Thank
Very
you, sir.
good work. Yeah.
Thank you, sir.
Thank you. Thank you so much. Thank you so much.
Thank you all. Thank you. Thank you. Over to you, Tangashankaran. Thank you.
Yes, sir. Thank you so much, sir. Participants will have a short break actually for five minutes. Already Pratap sir is, I think he's inside, sir. Pratap sir.
Yes, sir, I'm listening to
Yeah,
the
actually,
presentation.
Pratap
Nice.
sir, the second session
nice
resource person
presentation,
has
sir.
acted as a participant for this initiating session actually.
Actually, Palaniappan sir, I am on the consumer end in this technology. So I don't know the in-depth details of what goes between all those 7 layers and everything. But I'm a power system application engineer, so I use these IoT devices in power systems. So I know the benefits of it. What has changed over the course of years, from the 70s all the way to now. How where it is heading to. So it was good insight to know what's going inside the IoT layers. So thank you.
Thank you. Thank you, Mr. Pratap. Thank you. Thank you. And good luck
Thank you,
with
Participants, sir. Thank you.
good luck with your session, Pratap. Yeah,
Thank you.
Thank you. I hope I'll keep it as interactive as you did, but let's see.
Thank you. Thank you.
Yes, sir. So our participants will have a five minutes break, followed by which we shall initiate the Pratap sir session. Actually, we have seen the layers of IoT, and the second session will be the ditto continuation of this session, which is nothing but IoT in power systems. So that topic will be taken by the yesterday's speaker, Pratap sir, which is also who is also a renowned alumni of our institution. Pratap sir will start in another 5 minutes.
Okay, thank you.
And participants are requested to hereby fill the attendance link for the 5th session of Palaniappan sir, which has been posted in the chat box, and it has also been pinned here. So just please all are requested to fill the attendance form, which is mandatory for this Atal FTP.